Hello, welcome to Enlightning. We have a very serious and important show for you today about ingress-nginx, and I'm here with my guest, James. James, I have a really obvious first question for you, and that is, where'd you get that shirt? That Kubernetes shirt's super cool.
I got it at Barcelona.
uh, so Lisa's already like a Viking. You have a Viking as a guest. Vikings can work with Kubernetes too. Everyone, yeah.
Yeah.
For real, tell us about your get up here.
No, no. It's I want people to believe me when I said that I'm very serious about my Gimli cosplay. So I wanted to make sure I showed that I can't travel with the axe. Obviously, it's an actual weapon, but the helmet I need to start wearing more. And on Thursdays at Chain Guard, we like to wear funny hats. So figured I'd wear this hat.
Funny Hat Thursday. What's okay?
Yeah.
I have questions. Like when is the right time? When is it a Viking? First of all, I don't really know my stuff. Is Viking the correct? No. What
Oh no,
are you?
I'm a dwarf. I'm a dwarf.
A what?
I'm
A dwarf. A dwarf.
I'm
Okay.
a dwarf. Yeah, I'm cosplaying as Gimli from Lord of the Rings. I get it all the time because I have a beard. I'm stout like Gimli,
Okay.
so
Uh-huh.
I'm just leaning into it. So today you
And
have
then
me at.
and then how often do you have an occasion to really first of all, do you have more? Do you have like robes and stuff?
Yeah, I have a full outfit.
And then how
Not
often do you
like
have
genuine leather, but I need to work on it. Yeah.
how often do you have occasion to wear it? Just describe it that occasion.
Actually, the first time I wore this outfit, the full outfit, was my rugby team was doing a pageant show to raise money, and you needed to have like a gimmick, an outfit, and I was like, you know
Mm-hmm.
what? I haven't done it. I want to lean into it, and so I bought the full outfit for the pageant, and I helped raise $3,000 for our
Heck
rugby
yeah.
team. So it's
That's
absolutely worth
cool.
it. And then, any chance I get, it's going to be a Halloween staple from now on. Yeah, I'll
Yeah.
go to a Comic Con, anything like that. Like I need to start, like I said, I need to start traveling with this more.
Well, we have lots of buddies to say hello to in chat. Everyone who's here, please do say hi and where you're from. So we have Saud here. Hello. Hello, hello. Good to see you. Thanks so much for coming. Simon's here. Hi, Simon. And then, oops, as always, I have Lisa. Good morning from Massachusetts. And again, that's Viking awesome. So cool. Thanks so much for being here eventually. So, what's funny about this top part is like this conversational part. It like gives some time for people to stream in and say hello to everybody, but it's also like kind of intended to like establish trust. Like, who is this guest? Why do we trust them to teach us about whatever it is today? So I think it's I love that we're using the Gimli to establish trust. We have Kormaju's here. Kormaju, I'm so glad you're here. You asked the best questions. Thanks for coming, Kormaju. And Bushtan is from Mumbai. I was just in Mumbai in December. Cool. We have hello from Colombia also. Awesome.
All over the world. This is exciting.
Yes. Yeah. Streaming's so cool. It's so cool that we're all connected in real time right now. What is life? So let's establish some trust. We've established that you're fun. But
Oh yeah.
tell me who you are and what you do and how lightly, because I also want to ask about rugby, but just maybe introduce yourself technically. Yeah.
Technically, hello
Like,
everyone.
yeah.
This is James Strong. I'm a solutions architect at ChainGuard. I help secure the software supply chains. But what I'm really here to talk about is ingress-nginx. I'm one of the core maintainers for ingress-nginx.
That's awesome. I totally trust you now. I appreciate that. So before we jump into your story, and I have a lot of links I'm going to post. Before we do that, tell me about rugby. I know nothing about rugby. I know I've heard it's violent, or like, yeah. How did you get into rugby, and like, what's it like? What is it?
It is the best game in the world. It is
Okay. How did I not know about it?
great. Most people in America don't know about rugby, but
Uh-huh.
it's actually, again, like this all ties into like Philly and everything. Like, when you move to a new city and you
Uh-huh.
don't know anyone, what's the best way to make
Uh-huh.
friends as an adult? Right?
Uh,
Join a
yeah.
sports club. And rugby, they have a very social environment, and so they were at an event at the same local bar that I was at, and they usually have like a drink up after a game. They hang out with the opposing team. It's very friendly.
Oh,
Win or
that's
lose,
nice.
all friends. And I met the team that I play for, the Philadelphia Griffins, and I was like, I wrestled, I played football. I would love to do rugby. I've never tried it. And they like, we have 101 starting like in a week. Like, you should come out. And I did, and it's a year and a half, and I haven't looked back. I love it.
That that's freaking amazing. That's wonderful. So you're new to Philly. We have Findle here just saying hello real quick. Thanks so much for your little lurk, Findle. Appreciate your time. Um, this is cool. Okay, so let's get into the technical stuff. We have lots of folks here now. So I'm
Yep.
gonna move behind the light board, but we have quite a lot of links to put in the chat first. I think I'll put all the Nginx related ones. Well, what do you want to talk about first? Where should I start with the links?
Um, you know, the links can go in there. I'm going to talk about them as we come through.
Okay,
A lot of the Ingress
cool.
Nginx links are just, one of the things in my last talk that I found out is that, over communicating things is probably better than under communicating. And I found out a lot of people don't know about, updates and everything that we're trying to accomplish, releases. Like, a lot of people ask about release notes, but a lot of people don't read them. So I just wanted to
Uh-huh.
put those out there. So a lot of the links that we've posted, well, we've posted a couple more, but one of the links is a link to our meeting notes and how to join the community and where to get questions answered and asked. We've got a couple other things in there that I'll talk about, but Kubernetes has its own Slack channel, as most groups do nowadays. And ingress-nginx has two channels. We have a dev user channel where I hang out a lot, where we talk about releases, we talk about things that we want to try to accomplish, issues that we're seeing, and then we have a user group in Slack where folks can ask questions and get help from the community. So those are the two Slack channels that we have that we've just posted out there. So if you have any questions or if a PR is stuck, it's usually helpful to jump into the dev channel and just ask us to take a look at it, because we're all maintainers, and I get 100 to 200 notifications in my email from GitHub, and I'm probably gonna miss it. We're all gonna miss something, so it's just helpful to get in that channel and just ask the questions. But the best way to get something looked at is to join our community. Our community meeting. So as part of the
Ah.
SIG networking, it's helpful to join our community meetings. That's where we triage issues, we talk about releases, and we talk about issues that folks are having. So if you have an issue with ingress-nginx, join our community meetings, 11 Eastern, every 2 weeks. I think we have one next Thursday. But a little bit, just to recap a little bit of background. No, I can't hear you, Whitney. You're on mute.
Okay. I was gonna say if I was
Hey.
joining, if I was looking to contribute, I would be very just like knowing you for this short stream so far, just seeing like how kind you are and like how lighthearted and fun, that would be very compelling reason. I think I would of course want to be interested in the tech of the that I'm joining, but I think I'd be more interested in like the community aspect and like getting to know people and feeling safe that if I did make a mistake or something that they're going to be kind to me. So anyway, I
Whitney,
think you're doing a great job with the hat.
we all make mistakes, right? I learned, I think it was 2 releases ago, that we have a lot of GitOps folks who do automatic rollouts. And I pushed out a breaking change on a patch release, and I broke a lot of clusters very quickly. And we're all volunteers again, and we learn. So I learned. I didn't know that folks were doing GitOps rollouts on patch releases, and it was just I'll fix that for the next time, and we'll roll through it. So if you're there to help, you're there to volunteer, we appreciate it greatly. So no one's going to come down on you and be difficult or yell at you. That's just not part of the community, right? And that's also probably going to be a SkinCF code of conduct violation. So we try to be really welcoming and open to anybody who's willing to help out from a code contribution or documentation. Like, there's so much documentation that we have and so many ways that we deploy. Like, we need help. So it just doesn't serve us to be, have a high bar and, be, aggressive around that. So yeah, I completely want to reiterate that, if you want to help, we're there to help you learn and to help the project.
That's super cool. I want to say hi to Kumar. Hello, Kumar. Thanks so much for joining. And you're going to tell us some about your career journey to get to this place so far, yeah?
Yeah, I like to think about it like, programming and networking. It's all about paths and just making sure the paths line up to get to the goal that you need. And I like to liken that to the career progression.
Before you get in too much, I would love to just ask folks in chat, like, what's your experience with ingress-nginx? What's your experience with Ingress in general? Is there something in particular you hope to learn about the stream? So while we're hearing about James's career story, I want to know about y'all too. And now, James, take it away. Thank you.
Absolutely. I'm wondering how many people are going to join to drop PRs and ask about why they're not getting pulled. So I always joke about that in my community, like my talks, and I'm like, if you're here to talk about a PR, let's do that over a drink afterwards. But yeah, a little bit about my background. This goes all the way back to high school. I've been doing this for a little while now. I joined the CCNA Academy by the recommendation of my wrestling coach. And when I did that,
please?
The Cisco Certified Network Associate. So Cisco Certified Networking Associate. So it's the entry level networking exam for the Cisco progression. So if you wanted to be a network engineer, people started with a CCNA. And I didn't look back. I wanted to be a network engineer. I wanted to get that CCIE number. That's the highest level you could attain at the time. So Cisco Certified Internetworking Engineer, I think. So like at a time, I think they're still numbered. Like, it was prestigious to get that. Like, I wanted to be a network engineer. That's what I wanted to do. I was a network engineer at my university. I had my CCNA before one of the actual network engineers. I mean, he wasn't happy about that, but that's what I wanted to do. That's what I wanted to be. But when I graduated, I started at GE in a rotational program, and I was on the network engineering team. I was also on the cloud and Linux team, and for some reason I never touched Linux until that year. So it's like that, learning about programming, learning about APIs, system networking. I was like, and then the cloud started getting really big at that time, right? So I think AWS was around 2006. So this is probably around 2010, 2011. Popularity started shooting off, and I was like, I want to work in the cloud. So I have my networking experience background. I started my cloud journey then, and I was very interested in all of this. Kubernetes started getting very popular. I was like, I want to get involved in Kubernetes. So I started learning about that. And, the networking experience became very helpful, as we'll see, and as probably most of the speakers here know, that networking can get very complex in Kubernetes. So it's really helpful to understand the OSI model, IP addresses, natting, and all of that stuff. But really, it came ahead when I think through all of that, I was an AWS ambassador. I was posting, doing a lot of content, A Cloud Guru hit me up and said, hey, we would like a course on AWS networking and Kubernetes. I was like, yes, let's do that. And while
Heck
I was
yeah.
researching that, one of the ways that I learn about things is I read. I really love reading. So I read the Linux observability with BPF because I didn't know about BPF. I didn't know about EPBF. And I read that book. And at KubeCon, I met one of the authors. So I asked him some questions. I had some really in-depth questions. So Lorenzo Fontana, he's one of the, he's also a core contributor to EPBF. I was asking him questions, walking through the networking, through the course, and he was like, this would be a really cool book. So he got me in contact with O'Reilly. I wrote the book on networking and Kubernetes. And after I finished that book, I was like, what's the next thing I can do to help the community, to help learn about networking? And I've got to give it up to Pop. He's our sales guy now, but Pop, I asked him, he's a big community member. He ran the CNCF, I think it's CNCF TV, I can't remember, the podcast. I was like, what can I do to help the community more? And he pointed me to ingress-nginx. He's like, they need maintainers, they need help. I was like, I've never maintained an open source project. And I was just terrified. But again, like I said, the community was very opening. They were very welcoming for the help. And I've been doing that for the past, I think, 2 years now. And it's been really helpful. So sorry, that was a lot of a lead up to like understanding like where I came from and like my interest in networking and cloud and Kubernetes, but it all culminated to this conversation right now with my axe.
It's amazing how life does that. These different things you're learning and doing that don't seem related at all come together to make something that you just never could have guessed. My degree's in photography. I was a professional photographer for 10 years. And then now that I'm doing streaming stuff and have a studio, that's all coming into play. I hear an echo. Do you hear the echo?
I do not hear an echo.
Okay. Well, then we're not going to worry about it.
Roll with it. Roll with the punches.
Yeah, if other people hear it, then I want to know. But if it's just me, we'll get by. I want to eventually answer our question. They've been studying ingress-nginx for about 13 minutes now, and then Lisa says she appreciates your intro, which is wonderful.
Thank you, Lisa. Yeah.
They hear the echo too. So let's. So I'm checking my audio inputs. It's all through my iPod. So something in here. Oh, wait. Is it when I talk
I'm
or
muted.
Is it when you muted? So when James mute and then I'm talking, do you hear an echo? I don't hear an echo now. So if James is unmuted, we do hear the echo, right? So
I probably have it up too loud.
Okay. I don't hear it anymore. So whatever happened,
folks.
It's great.
Oh, hi, Long. Long's one of our supporters. He's amazing. Thank you for joining. He helps do triaging support. He helps like non-code contributions, but still very helpful. He'll help triage issues, walk people through support. Very helpful from a community perspective. So thank you, Long.
Thank you, Long. And also thanks to Nick, the first one who comes to many streams. Good to see you again, friends. Thanks so much. Usually I like to start this conversation like with what was the world like before ingress-nginx? And I do want to answer that question to give context, like why did ingress-nginx need to be created? But then I also want to clear up some terminology around ingress in general, because I think it's pretty confusing if you haven't really been in the space like me to what's an ingress controller, what's an ingress Kubernetes object, what's a custom Kubernetes object that's being controlled by an ingress, like kind of maybe demystify or untangle the jargon a little bit before we jump into everything. Do those two objectives sound like a good way to start to you?
That's exactly how I plan to start the conversation, because I always,
hell yeah,
I'm going to assume like base networking knowledge, and then we'll just build on like Kubernetes networking and how it's all laid out. And then we'll build up to ingress, because ingress is built on top of other networking constructs in Kubernetes. So it's always good to understand how those work. And then you can get to how ingress works, and then how ingress-nginx uses all of those. So I absolutely agree.
Yes. Awesome. We have Long is given some love right back to you, James, which is great. And Phispheric here. I love when Phispheric comes because Phispheric is great at puns and also asks good questions.
I love puns, so bring them on.
All right. So I'll let you guide things from here.
Okay. Where to start? This might be way too far back, so people in the audience let me know, or Whitney, you let me know. But I think we'd start with like the Kubernetes networking model and how Kubernetes views the world from a networking perspective, and then that again builds on top of how all of the other services work. So the Kubernetes networking model has 4 pieces. One is, there's, I'm going to read it and then we can talk a little bit more about it. Highly coupled container-to-container communications. So that's how pods talk to each other. So pod is the atomic unit in Kubernetes. They get an IP address and they should be able to talk to each other. So that's what they talk about when it's like highly coupled container-to-container communication. And you let me know if I'm talking too fast, because I know you're writing as I'm talking, and this is a new medium for me. So you let me know if I'm talking too fast.
Yes, I will be a great communicator.
Right. So that's the big focus, is the pod-to-pod communication. And then we'll talk about services as we get there. Networking from that perspective is pods to services. So how do we tie pods together of like applications? So Kubernetes, it's a distributed application, right? If I want to run 1,000 instances of something, but how do I tie those together? We tie those together with services. So that pod to service communication is one of the next pieces of the Kubernetes networking model. And then all of this is internal to the cluster, right? So all of this traffic, services to pods to pod, all of this is internal to the cluster. So we talk about it from a networking perspective: internal, which is cluster traffic, and then external, everything outside of it. And we'll eventually get there with ingress-nginx and load balancers and all of this stuff. But then the third layer, right, is external to services communication. So that's getting traffic into the cluster.
Okay.
So I would just be like internal to external.
Yeah. Services tie pods that are running the same application to one another, or group pods that are running the same application.
Yeah, they group them together. Yeah. That's probably the best way to view that, is the grouping.
Okay.
I'm gonna see how long the helmet lasts. It's not that comfortable. It looks cool, but it's not that comfortable.
Your helmet. Oh, it does not look even a little bit comfortable. It looks pretty miserable, actually. So now
external, and then external traffic.
External coming eventually says, heavy is the crown. Okay, so then we have external to service communication, you said. So we need to get traffic from external to a Kubernetes cluster. Okay.
Yeah.
Okay.
And so that's the networking philosophy, what we call the networking model in Kubernetes, and that's the basis for how all of the other things flow, all the way up to ingress and ingress-nginx. So that's a good starting point, and then we can start talking about and defining the things that you were asking about. Because I think you started with asking about like controllers and things like that. So most folks who are using Kubernetes understand like the pods run on hosts, and hosts are run all of that. So we have the pods running on hosts. But from a networking perspective, how do we get the networking configured? How does the pod get an IP address? And Kubernetes is big on yes.
When you say a pod's running on a host, do you mean the machine, the computer it's running on? That's the
Yeah,
host?
yeah, the
Okay.
machine that's running the kubelet, because the kubelet's managing everything on a host. So if I say I
Okay.
want 10 pods, Kubernetes will go and distribute those 10 pods to a host and get them running. But as we said, Kubernetes is a very distributed system. There's lots of software
Uh-huh.
that's involved. So it's not
Uh-huh.
just one monolith. I mean, the API can be seen as that, but there's still lots of other pieces. And one of those pieces
Yeah.
that's very important is the container networking interface. That's the piece of software that's responsible for setting up all of the setting up the networking on a host for when a pod starts to run. So that's the one that's responsible for the pod to pod pieces, and also
Okay.
the services. So I would say like the container network interface is another really good place to start from that conversation perspective.
So you said there are four parts to the Kubernetes networking model. Is the container networking interface the fourth
Um,
part?
yeah, the first one is tied to both of them. So it's like highly coupled container to container communication. So
Uh-huh.
when we run a container,
Uh-huh.
containers run inside pods. So a pod can have multiple containers. So
Uh-huh.
containers can talk to each other on local hosts. So
Mm-hmm.
that's the fourth one. So that's the one I kind of glazed over when I went right into the pod to pod communication. So
Okay.
yeah, one of the examples that's used to explain this is like logging or sidecars. So you can have
Mm-hmm.
multiple containers running inside of a pod. So your application
Mm-hmm.
container is running your application. That's the only thing it should be running. You
Mm-hmm.
can have a sidecar, or you can have other containers running alongside it that are responsible for specific tasks like logging or network proxying. So that's the
Mm-hmm.
container to container communication, and that's all done on local host for
Mm-hmm.
that connectivity. So that's the four layers, right? Container to container inside of a pod, pod to pod, pod to services, and services to external. So that's a good point. I did glaze over that one very quickly.
Share the same network and refer to each other as localhost. Okay.
Yeah.
Okay.
I was very concerned about the timing, and just as we dig into this, I don't think we're going to have any issues with the timing.
You're like, how am I going to fill up that much time? It's never been a problem. So maybe do you think it makes sense to kind of draw this out maybe right here?
Yeah, yeah. We can walk through
So, I
that.
mean, is it important to the story? I know we're throwing a lot of
I,
stuff around and yeah.
yeah, no, I think for the folks that are following along, it might be helpful to like draw those out. So maybe we can draw like a Kubernetes cluster with 3 hosts and a pod on each host and a couple containers in the host, or a
Okay.
couple containers in the
So
pods.
so when we say 3 hosts, we're probably talking about worker machines, or are we concerned with the
Worker
control
nodes,
plane?
yeah, they used to be called minions. They're worker nodes now. Yeah.
Okay.
So yeah, I would say
So
3 worker nodes, a
okay.
VM, EC2 instances, things like that. Um, I forget what I think they're called worker groups in EKS on AWS. So you can have multiple nodes. Yeah, you got it.
Okay.
And then yeah,
Do you know what's funny is so I'm like a very new learner. Well, relatively now. I've gotten a lot of one-on-one sessions from experts, so I can't I'm not a beginner. But like when I was first starting, one of the really hard things for me was I didn't understand that a node was the same thing as a VM, was the same thing as a box, was the same thing as a machine, was the same thing. It's just
yeah,
all just a computer. And so it's hilarious to me that you're introducing the word host in here. Like there's another word
it's
for
a
it
new
that I
one,
didn't
right?
even know. Yeah.
It gets even more confusing when you start talking about like software like Kind, where they're running Kubernetes in Docker. And so you can have Kubernetes running on Docker on your hosts when they're just the hosts are now containers, and it just it gets so confusing very quickly. So
Do you
yeah.
want to represent kubelet? Do you think that's important?
Yeah, we can do like a small k.
Okay. A little I'm gonna write kubelet.
Little k.
Because K is for Kubernetes too, and then kubelet.
Yeah.
Okay,
And,
so each one
and the
has
small
kubelet,
k I
right?
think is like k native. So let's not do that then.
All right, and then we're just doing one pod on each of our hosts. I guess I'll make it green.
Mm-hmm.
And then each pod is going to have 2 containers.
Yeah, that's fair.
And then in our hypothetical example, these pods are all running the same application.
Yes.
Okay, cool.
That's one of the other things that's really difficult. Like when you've been working with something for so long, you gloss over assumptions or you miss things. Like as a solutions architect, I work in support a lot. And so it's really hard to understand, like, assumed knowledge is very difficult. You don't want to assume too much, but it's like, how deep do you go? And like, so it's great that I have you to help me guide this, because I just assume people know things, and you can't really assume that. It's not helpful for a new learner.
Yeah. And this it's a lot of words. So, and for me, I'm a visual person. So now I have the situation that we kind of described. So maybe we'll talk about these network models in term so when we're talking about we are putting one pod, like if there are 3 machines in our cluster and we're putting one pod per machine, it's very possible that 2 pods could be on this machine and 1 pod could be on that machine, or pods are ephemeral. So they might go down from this machine, but then pop up on this other machine. So that's maybe an important thing to just note verbally. So then when we're talking about highly coupled container to container communications, that one's like different containers running the same
pink and yellow are talking to each other. Yeah.
So so I have 4 colors and there are 4 things. So let's say we'll represent this one in orange. So these pods are connected to each other through this way, right? And then also they're all connected to each other, right?
Yeah, they are. That is one of the principles of Kubernetes, is that the Kubernetes networking model is that all of those pods should be able to communicate to each other with their IP addresses.
Oh.
So yeah.
Okay. And then we have pod to service communication. Ooh, we haven't talked about a service. So
services are they're defined through I don't really want to go too deep into the IP tables and everything, but like a service is a construct in Kubernetes that ties these pods together so you can identify them as one unit. So I would just say, like, external to that, I would just say service. And the default service type we can talk about is the cluster IP.
So we'll just put the service out here. It could be running on any machine.
It's defined on all of the machines. That's how it's distributed. But yeah, it connects everything, so it can be external to the hosts out there.
So this is our service, and it basically connects to all 3 pods, and it gives the pods a single IP address that you can access any pod, right?
And this is all still internal to the cluster.
Yes. We'll draw the line around the cluster at the end.
Yeah. One of the other things too we want to talk about is endpoints. So when you create a service and you create this grouping, each one of those pods now is an endpoint that's identified. So I would just like a little bump onto the services maybe, because that's how it ties everything together. This gets important further down the road when we talk about ingress-nginx. So yeah, that's yeah. I like that. The little star, that's an endpoint.
Still on the page, yeah. Cool.
Awesome. Okay. So this is the internal communication. That's that second point. And then I guess we can now draw the perimeter for the Kubernetes cluster itself. So all three of those hosts now make up our Kubernetes cluster.
Okay. Okay. I know enough about ingress to know that I feel like I want to leave a space for it. So this is our
Yeah.
and
Yeah.
yeah.
I would say just like straight down to the endpoint, and because the ingress it straddles both internal and external communication. I mean, that's its whole point, right?
Right. Mm-hmm. So I want to do this, then have it be part of the perimeter of the cluster.
Yeah.
How's that
I
feel?
like that.
Yeah, cool.
Yeah. Excuse me. Sorry, folks.
So
Yeah.
external to internal communication happens through the ingress. We haven't used this.
That's what.
Yeah.
That's one way that it happens. Yes.
One way that it happens. Ooh, enticing.
One way that it happens. Like I said, like as we talk about it, it gets more and more complex. So it's always helpful to like draw it out.
Yeah.
Awesome. So we've defined that. We've defined all of that. We won't. Node ports will get confusing, but I think this gives us like the perimeter around the clusters where the communication happens, and so all of these are all objects in the Kubernetes resource model. This is how we define the Kubernetes networking model. So this is like theory into practice, and now we can talk a little bit about that. And one of the things I did talk about, I wanted to, if we could just draw like an arrow between the pods and the kubelet, like the CNI, because the CNI is very important for defining the networking on hosts. Yeah.
Okay. I'm off in my own little world. I'm making my own little key. Okay, so we want to talk about how the pod and the kubelet talks to each other. Blue is probably the best for that. And that's the CNI.
Yeah. So a CNI, again, is a separate piece of software. When the kubelet gets the request to start up a pod, it asks the CNI for an IP address. It creates all of the networking interfaces. And then it does a whole bunch of other things too, depending on which CNI that you have, right? There's tons of them out there. There's Cilium, there's Calico, and each of the clouds even have their own CNI, and you can use CNIs together. So again, it just explodes in complexity and then what you want to do. So, yeah.
Cloud networking interface, right?
Yep.
Cool.
It's its own separate project, has its own spec, all of that.
And then I would like to capture on the board, like you said so many things, but maybe like either a succinct definition, or I can bullet point all the different things that you said, whatever you think is more important to the story.
Okay. Around what a CNI is?
Yeah.
It is responsible for the networking, for the pod networking on a host.
Okay. And how's that got to do with the kubelet?
The kubelet talks to it and says, give me an IP address. I have a pod that I'm spinning up. Give me an IP address, create the port, and it does all of the work. So again, Kubernetes is very big on specific software doing specific things, and then having interfaces between them. So the interface between the kubelet and the networking is the CNI.
The kubelet and the networking, not the kubelet and the pod, but the kubelet and the networking.
Yeah, the networking for a pod. As I keep talking, I keep hearing I'm very thankful for you to like help navigate the confusion that I'm now pushing in all of this.
Networking for a pod. Okay.
Yep.
And many implementations, Celium being one of them.
There
right?
are many, yeah. Yep. Just like there's many different implementations of ingress that folks can choose from, ingress-nginx being one of them, the same thing from a CNI perspective.
Or like a container runtime engine perspective.
Exactly. Yeah. So, I mean, even from so all of those pieces, right? The compute is the kubelet. You have the networking, the CNI. You even have a storage interface, right? So storage interfaces have multiple implementations. Yeah. So same thing here.
Cool.
So what happens when you have an open source ecosystem? Everybody has their chance to say how they want to do things, but they all have specifications. All of them have implementations. Yeah.
Cool.
Excuse me. Sorry.
We're off to a great start.
So yeah,
I'm having a blast. Yeah.
Good. Yeah.
Good.
So all of this just defines how the networking works, how everything gets. Like I've got 3 pods. They've all got IP addresses. They're all talking to each other. We have a service, and then we have ingress, and then we can talk a little bit more because ingress uses very many of the service types. Maybe do we want to talk about the service types?
I don't know the relevance to the story, so I have to rely on you about what is important for your story.
Yeah, I think so because the service types define, because you can use them for external traffic with or without ingress, and then ingress uses all of them. So there are there's 3 that we're concerned about. There are 5 types, but there's 3 we're concerned about.
Okay.
So there's cluster IP.
All right.
Yep.
Okay.
Node port. And then load balancer. Excuse me. So all of those will be used. We got a question. It looks like, I think that's from YouTube. Is it the CNI's job to connect any new pod to existing Kubernetes networking? Yes, that's the part that we were talking about. So the CNI will provision the IP address from the pool. It'll create the networking interfaces on the hosts. It does all of the mapping for it. So yes, the CNI is responsible for connecting it to the Kubernetes network.
Thanks for that great question, Drew.
Yeah.
Oh, we have another question. Why does ingress-nginx choose annotations-based implementations that are close to 119 annotations?
Jumping right into it because I was going to talk about that. To answer the question quickly before we get to that, I don't know why we chose the annotation-based approach, but it does make it highly configurable. So anytime you want to make a change or add different behavior, you'll use an annotation. And like he said, there are 119 of them, and we'll talk about that when we get to the ingress-nginx piece. But yeah, it's a lot. It's also a lot to maintain, and it's one of my talking points too that I want to discuss. So thank you for that, Kumar.
Thanks, Kumar.
Good question. So cluster IP, when we talk about that, that's the default type if you don't specify one, and that gives you that service IP address. So you can, inside the cluster, you can use that IP to talk to all of them. So service-to-service communication will use that IP address to communicate with each other. Node port is an interesting one because that's when we first start talking about external traffic. So when I want to deploy a service that's of node port type, what it does on the host, it will provision a high-level port. So say my application's running on port 80, not every application can run port 80. When I provision a node port, it's going to do a level 30,000. So it allows me to the IP address of the host from 30,000 pod IP 8. Because remember, pod IP is internal to the cluster. So I can't talk directly to a pod IP external to the cluster. So I can provision a node port service, and I can hit that host IP address at port 30,000, and that service will do the mapping to the pod IP address on port 80 for me. So that's why when you provision a node port service, it will provision port 30,000 on every host, and I can hit the IP address of the host at that port on that service.
So on our 3 different machines here, the IP of the machine at port 30,000 would be how you would hit that pod or that container in that pod, if you had a node port service. How can you help me with that? I'm echoing again on your side. If I don't know what you did before to make it stop, but I can hear the echo again. Can you turn me down or do it? Yeah. And then question. What's a quick synopsis of what a node port does that I could write here?
Host to pod mapping.
Host to pod. Great. We have a question in chat right now.
We have an ingress-nginx question in chat.
Why am I not able to host multiple applications with nginx controller? And then example, I'm getting the first login pages from there. I'm getting an error. Where would be this? Maybe this medium, and this isn't quite the time because this is going to involve some more advanced troubleshooting. Where would be a good place for them to ask this question? Thank you for your question.
In the user Slack channel we talked about.
Okay, so in the Kubernetes Slack, in the Kubernetes Slack workspace, there's a ingress-nginx user channel. That would be a great place to put this question. But thank you for asking your question and participating. We're glad you're here, friends. So I can hear myself on your side, James. No, I can't see anymore, but maybe you just muted. Okay, so we have cluster IP, we have node port, and the third one you said was load balancer. Oh, are you just frozen? I think you might just be frozen. No, you're not. Okay.
I was playing around with the settings.
Ah, gotcha. That seems better. That's better. Hopefully. No, I can still hear myself in your background. How you had started charging your headphones during pre-show? Do you think maybe?
Yeah, let me see. And it's an excuse to take my my helmet off.
Yeah. What's strange is that it comes and goes, you know? Boris thinks that maybe you have your mic connected to one device and speakers to another one. But we're trying the headphones. That should get her done.
Okay, it's connected now.
Eventually says, I did not expect that blue hair. I love it. It is. It's like a fun reveal. So one thing I didn't understand while he's doing that about Ingress, and maybe still I'm wrapping my head around, is I learned. Ooh, now it's bad. I almost don't want to speak. I almost don't want to speak to hear my own voice.
Front, right.
It's like we can hear your headphones. Maybe you have your headphones set as the microphone instead of the speaker. There we go. So now there's no echo, so that's good. Can you hear me? And then can I hear you? I'm going to keep talking. So I learned Ingress is kind of a big beast, and when I would try to look it up on like Kubernetes docs, I would see so many different implementations of Ingress, and I was confused by why there are so many and why some of them are project managed and some are not. I was confused by why some say Envoy and some say Gateway, and some there are like multiple Envoy ones, multiple Gateway ones, multiple Nginx ones, Nginx. And then I understood a Kubernetes ingress object, and I understood you needed an ingress implementation. But what I learned from the emissary ingress episode is that implementation. This is hard to listen to. What's the difference? Oh yes, nice.
Yeah, so there's always a million switches. I had my audio on here and the mic on here, but you can also switch it in the streaming software. So I apologize for that. Is everything good now?
Yes, it's wonderful now. Thanks for taking the time to fix that. We have a question that I actually think I can answer. I would like to try to answer it, and then you can double check my work. But what's the difference between Istio and Nginx Ingress? So instead of saying those exact two technologies, let's talk about what is the difference between service mesh, which Istio is service mesh, and Nginx Ingress, which is an Ingress. Ingress conserves itself with external to internal traffic with your Kubernetes cluster. That's the Ingress's job. And then service mesh, like Istio, is concerned with all of the traffic just within the cluster, like all the ways different things talk to each other within the cluster. How do you feel about that explanation?
You are right. Yes. But in Istio also has an ingress and egress gateway, and it can control internal and external traffic. So yes, you are right. So there's service meshes, which are both for internal and external traffic and pod-to-pod communication. So one of the big use cases for service mesh is encrypting traffic between those two pods, because again, the pods are talking to each other over the network, and it's all unencrypted. So service mesh allows you to encrypt that traffic between the two pods, and but it also allows you to have communication internal, like code programs like Istio have, and they have the internal communication. So it even further it. So you have mesh, you have ingress, then you have the new ones out API. So Gateway API is an evolution of ingress, and it's one of my talking points too, because I know folks have been asking, when is ingress-nginx going to support Gateway API? And Gateway API is, when I say it's an evolution, it's still a layer 7 external to internal communication, but it gives you a little bit more flexibility in the roles. So it breaks up the roles of who can do what with the traffic. So yeah, there's a lot more nuances to all of those.
We have a lot of supportive comments from the chat. One is eventually said it's like international versus domestic travel in terms of service mesh versus ingress. And then live coding is like classic sound issues, very common. And then also you were breaking up a little bit, like it sounded just like audio static, but you seem to be fine now. But being very supportive, thank you, live coding. And then Kumar says, I think the learning curve of Ingress is hard because it involves a domain. I don't understand it well when I switched to Google domains, and then the fun started. So that's like incorporating a DNS element to it. That also makes it hard. Another level of difficult.
So I was eventually going to get there too because we're more working up to ingress. Like ingress is a
Uh-huh.
layer 7, and so it has a host aspect. So ingress allows you to have one load balancer for the entire cluster, but you have to
Oh.
differentiate the traffic, and you do that by setting the host. So I can have all of my hosts I can have 10 different domains mapped to the same load balancer for ingress, and then I have to route that traffic. And we do that routing
Uh-huh.
based off of the host and then the path. So say you have mydomain.com/API/foo. Using those two pieces, I route the traffic to the specific service. And then I
Uh-huh.
have, mydomain2.com/API. Again, that's a separate ingress object, and that's how we route the traffic. So it does add a complication to how you learn this. So yeah, but
So
that should be the same for yeah.
once I do want to go into that a little more in depth later when it makes sense in the story. And what
Yep.
I'm learning, I think, is to keep this area open. Like we might maybe need it to write out domain names of how stuff is going to get into the cluster. Yeah. Um,
Yeah.
cool. So we were just before all the audio issues, we were talking about load balancer
Yep.
service type. And is it related to the load balancer you were just talking about?
Yes. So
Okay.
the third service is a load balancer that's important for ingress, is that it will provision an external load balancer. So like I used to be an AWS
Mm,
ambassador. I still do a lot of AWS work, so I'm going to use the AWS reference, but it works across all of the clouds. So when you provision a load balancer service, it provisions an external load balancer in AWS. So
ah,
it'll do all the different types, and then it maps. So this is where the mapping all comes into place, and where everything's taken care of for you from a networking perspective. So I'm going to provision a load balancer service. It also provisions the node ports for you. So if you think of these as a hierarchy,
mm-hmm.
it's going to provision the node ports for you for the service to service communication, and then the load balancer is now your external entry point, and it talks to all of those node ports running those services.
That is very helpful.
Yep. So
I
like
knew
it's
these
all
service
starting to
types
build.
before. Yeah, yeah. And I didn't know that load balancer provisions node ports for you, so that really helps solidify my mental model. We have a question from Sravan. Is there a document or something which can be used to select which annotations are to be added when I create a new English rule? If you send it to me, James, in private chat, I can put it into the chat for the show.
Yep. We have a whole page that maps all of them out in our documentation.
All right. All right, there you go. There's your link, friend. Look at that incredible teamwork, everyone. All right. What's next?
Now we can talk about ingress, and then ingress-nginx specifically.
So
Yes.
this service we drew here is a cluster IP service.
Well, that one's going to be a load balancer service now,
Okay.
because we're going to change it because you can change services.
Okay.
So now it's going to be a load balancer type for us. Um,
Okay.
because when you deploy ingress-nginx, we deploy a service of load balancer type because we need that load balancer to talk, and then we define all of our ingress routes through that load balancer. So this service is part of the ingress deployment.
Okay.
Yep.
Cool.
Okay. So when we deploy the ingress, we deploy a service type of load balancer. Now we have one load balancer. So if we want to draw like an external load balancer outside of that, next to the
Mm-hmm.
ingress,
Cool.
Yeah.
Excellent. Nice.
Yep. So now this is the typical setup for an ingress that will get deployed, whether it's emissary, it's contour, all of the other ones that you want to talk to, the very many um, myriad of choices that you have. So this is an ingress deployment. When you deploy ingress-nginx, it deploys all of these Kubernetes objects for you. So you can deploy it via Helm chart. You look like you have a question.
I do. When you say all of the objects, you mean the load balancer, which then makes the node ports?
Yep.
But then
And
it's
then,
not nothing. It doesn't deploy the pods.
so I think you asked at the very beginning, like controllers and things like that, and how all of this
Uh-huh.
works. And then this is where
Uh-huh.
we get into the controller part of the ingress-nginx controller. Those are also pods that have to
Uh-huh.
manage the configurations and listen to the ingress requests that folks are going to put in. So the things that Savan asked about. Hey, Ricardo. Ricardo just joined. He's one of my
Hi,
other
Ricardo.
maintainers.
Cool. Hello, welcome.
He said he was going to join, so I'm excited, and he's going to correct me on everything I say wrong now.
Let's do it.
No, he's going to help me learn. He's going to help me learn.
Yes.
Um,
Yes.
so when we deploy the ingress-nginx, we're also deploying Kubernetes resources to manage all of this. And again, from a controller's perspective, a controller in Kubernetes parlance is a piece of software that watches for changes to specific objects. So the ingress controller is looking for ingress resources to deploy. So as a client, I'm going to ask Kubernetes, deploy this ingress resource, the one that Savan and others have talked about. I want to be able to route my traffic to this service, all of this. So we have to have software that manages that and watches for that. And this is where we get into the differentiation between all of the other ingresses. So ingress-nginx, to manage all of that network mapping, uses nginx to do that. So does that
So
help?
I want to capture, yes, but I want to capture kind of what you just said. So when you deploy an ingress, you're talking about deploying an ingress object, and then that
Controller.
object, an ingress controller. Okay, so not the object, but the controller. Okay.
Yeah.
Cool.
So when we talk about ingress-nginx, it's a controller, and you have to deploy that into your cluster because Kubernetes doesn't deploy that for you by default. It's up to the admins and the users of which controller they want to deploy. So when you deploy an ingress controller, it also deploys all of the resources to manage ingress objects. So again, like I said, we're building up to ingress-nginx.
This is great.
And hopefully this helps make the other conversations you have about ingresses easier. And it's just, I feel like we said, I don't know how far back you ever want to go, or like you don't want to assume things. So I hope this is helpful.
This is very helpful to me. I hope it's helpful for everyone else out there too. So, and then when we say the resources to manage ingress objects, so we're including like an ingress object, and then we're including a load balancer Kubernetes service, and then we're including an external load balancer. Is that true?
So that's all. So there's
What do
two
we mean when we
resources
say all of the resources? Yeah.
All of the resources. So ingress controller is a pod. It's a piece of software. So pods have to get deployed to namespaces. They have to have, for ingress-nginx, it has to have a config map. There's RBAC for it. So all of the Kubernetes resources to run a ingress-nginx. That's what I talk about when I say all of the resources.
Okay, cool. Great.
And this is going to help start to understand like some of the complexity when I get into the specifics around how we manage ingress-nginx and all of the software that's involved. So there are, I think I think there's about, I'm going to be wrong with the number, I already know, but about 20 or so resources that our Helm chart manages. So it's the RBAC, it's the config maps, it's the actual deployment of the ingress controller. All of this is when I talk about the Kubernetes resources.
Cool. So it's basically anytime you would install any Kubernetes add-on, you're deploying these types of resources. So it's the same thing as that. Okay.
Yes. Because it's all, again, it's all software in Kubernetes to manage other Kubernetes things. As the saying goes, it's turtles all the way down, right?
Turtles all the way down. Yeah. All right.
And then we have what we talked about with ingress objects. Ingress objects, an ingress resource that defines how we route traffic into the cluster. So there's the ingress controller, and we have ingress objects. The ingress controller watches for ingress objects to be created. So that's the stuff that folks were asking about. So that's route my API request to this service. And that's the ingress object.
Okay. And this here is an ingress object. An ingress controller is like the software that's installed.
All of that you just pointed at is the ingress controller that we just mapped out.
Okay.
We haven't deployed any ingress objects yet.
Okay. It watches for ingress objects, and I wrote ands, but I don't remember the second half of what you said.
No and.
No and.
I probably just went into defining what an ingress object is.
And then an ingress object. Where's my face? I'm gonna leave room for it. And what does an ingress object do?
So that's the mapping. So I have, like we've talked about at the very beginning, I have 3 pods running my application, and I want to get traffic into it. How do I do that? Well, we're using ingress to do that, and I have to put in an ingress object that maps my host, which is what one of the people were asking about, and the path. So the domain and the path will set up the routing for us to the service and the pods running inside the cluster.
So an ingress object is the mapping between the domain and, I mean, really the running application, but we could say the domain and the service.
So you need the host mapping, so you need the domain, and so like that little slash. So you could have 2 versions of your API. So you could have my domain /foo, and then foo1. Those can be 2 separate services running inside your cluster, and you can define all of those in an ingress object.
I want to come up with we're going to call our domain Viking. So we have like a Viking.com, like /helmet. Or should it be dwarfed to be more true to what you? Yeah.
Well, we could have a separate ingress object too. That's like Gimli.com.
Okay.
Because that's a separate. GIMLI.
Gimli.com. So if it's okay. And then this is our ingress object, but it's actually running in the Kubernetes cluster.
So those are 2 ingress objects. Those are 2 separate ones. So it's
yes.
Yeah.
So do I need more space between them, or do I need to write?
That's fine, because we can branch out to like multiple paths. So that's the domain plus the host.
I need to be able to see you.
Okay.
Awesome.
And so that's how we define an ingress object. Yeah.
Cool.
So we've got 2 ingress objects. So So that's the first part of the mapping is the host and the domain, the host path and the domain. And then we need to tell, as part of the ingress object, what application to route those to. And that's the services piece. So you need the three pieces. You need the services, the host, and the path. And then inside the services, you need the port that the application service is running on. So that's the other piece.
So in your ingress object, you define service, host, and path,
Yep.
right?
Yes. And that was part of the question that we were being asked about earlier.
So by service, which type of service are a node port service?
That's going to be a cluster IP. Yeah.
Oh, I keep
Right?
getting it wrong.
I think that's right.
So, and then by host, we're talking about our domain name, right?
Yep, the domain name.
And by path, what's that?
So you could have multiple services on one domain. So you can have like your scheduling service, your calendar service, your
So,
distribution, your cookie service. So that's
so,
like /API /API v2. All of those can be separate ingress objects to go to
so,
different applications.
so subdomains would be an accurate way to say that?
No, it's the HTTP path after the domain. So
Okay.
anything after the domain,
Oh, okay.
that's where
Got you.
we do
Got
the
you.
mapping. Yeah.
Okay, I see.
A subdomain would be a new host, which would be a new ingress
Would be like,
object. Yeah.
gotcha. Cool.
Yeah, it could be like api.gimli.com. That'd be a new host.
So I go to gimli.com and this is running an Axe, some sort of Axe related software. So I go to gimli.com and then does this ingress object hit the external load balancer or is that yes?
Yeah.
So then it goes.
So we're mapping the host name to the ingress's load balancer's IP address, and then inside that we have the routing that points us to the service that's running all of that.
Okay. And then the service gets it through to the running application.
Yep.
Where is, but isn't this running in the cluster, the ingress object?
So that's the path and the service piece. So the service is the software that's running the Axe service under gimli.com.
Okay. So so maybe there's several ingress objects that each. I'm concerned about the cluster boundary and when does it get in the cluster and how. If this is our ingress object.
Yep, our ingress object has to have a service running. So the ingress controller has its own service. Every ingress object has to have its own service to define that software. So that's how we get the mapping to your running software in the cluster. It has to have a service. That's how we do that.
Cool. Awesome.
So now that we've got the ingress object, which is the best to use, I'm going to be biased and say ingress-nginx.
So far it's been great here. There's also an Enlightning episode about emissary ingress, and we're going to do Contour tomorrow. So we're doing all the CNCF ingress projects as Enlightning episodes. But
so we've got we've got all of this defined. So nginx maps all of this for you. So ingress-nginx maps all of the ingresses, map everything. So it's monitoring for an ingress resource. It does the mapping for you. And now we can start talking about like the specifics of ingress-nginx. So
I would love just like a definition of of ingress-nginx? Like a good old-fashioned ingress. Oh, ingress-nginx is fill in the blank.
Ingress, an hour and 15 in, right? We get to define it. Ingress-nginx is an Kubernetes ingress controller that uses nginx to maintain the ingress objects.
And then I think we probably need to level set on what nginx is. That uses nginx to do what to custom resource objects?
To maintain the ingress objects. Or configure might be a better word.
What, maintain and configure?
Yeah, it does both.
Yeah.
Ricardo put in a point that I was going to talk about. It's a very nuanced point with ingress-nginx.
So part of what makes this conversation hard is just the distinction between an ingress object and an ingress controller. And a lot of, not just here, but in the whole space, I see just the word ingress being used to describe either one. And it's part of what makes it hard to understand for me.
And that's why I like to say, like, the controller versus the object. So I'll try to continue to use that differentiation when we're talking about, because now we're getting into the part about configuring an ingress object. And that's where it gets into like questions like Savan had, where the annotations and the domain things being confusing, that's all around the end user. Most folks interfaces with ingress is going to be through an ingress object. The Kubernetes cluster admin or another team, an SRE, DevOps team are probably going to be managing the deployment of a Kubernetes cluster along with all of the other bits. And one of those bits is the ingress controller. So everyone's interaction with ingress for the most part is going to be the ingress object.
That's a great point about the personas. Okay, let's talk about Ricardo's comments. A comment: when the service that backs ingress is not of external name type. We didn't even talk about external name type.
I left that out on purpose. Yeah.
It will use the related endpoints Kubernetes object to get backend IPs.
So we're kind of at that point where we're to talk about what he's saying, because we've defined an ingress object. You've defined a service that points to your applications. And then we can get into how nginx configures that. So nginx is a load balancer proxying software that now is owned and operated by F5. So nginx Inc. is the open source software for that.
So maybe worth writing here not to be confused with nginx Inc. Ingress.
Yes, I think I have it saved in my notes to send you. We get this question a lot. What's the difference between the two? There are varying differences, and we have it outlined. We have it outlined in an issue. So that's why when I say ingress-nginx, that we just literally just updated all the documentation to make sure that it matches with the naming. So ingress-nginx, and then there's the nginx ingress controller. And that's the F5 nginx Inc. ingress controller.
All right. See, I think when you were having your technical difficulty, I was talking about my experience trying to figure out what ingress was and going to the ingress controller page in the Kubernetes documents and seeing like all kinds of words I didn't know and lots of things repeated. And this is, just an example of why I felt overwhelming. Oh, Ricardo, sorry, I thought you passed it. That's okay. It's better too much information than too little, and that's what I think. Kumar says, I want to understand the naming convention. Why is domain called host? Why don't we simply call it domain? You're speaking my language, Kumar, in the ingress spec.
It's a host name. It's a domain. I think let me go. I think I had it pulled up. What is it? what do they actually say that it is? Is optional host. A host is not specified, so it in the documentation is even confusing. But it is a domain name. It is, what do you want to map that domain to, that IP address of the ingress-nginx load balancer, right? So that's why it's a domain name. It's a host name, right? Because you can have, you know that it's just all part of it. It's welcome to tech. Sorry.
And then Abdurrahman is asking, probably for me, why is VMware Tanzu implementing Contour as the main Ingress controller? We have a Contour episode tomorrow. We have one of the Contour maintainers on the show. So let's come back tomorrow and let's talk tomorrow about it. Awesome.
Yep. Everybody has their implementations, right? Even,
yeah.
I mean, AWS has their ALB controller that also satisfies the ingress resources. So it's open source. It's a spec. Everyone has their opinions on how it should be ran.
I feel like in the Kubernetes docs there were like 20 of them, like different ingress controllers. Yeah, there are a lot.
Yeah, there are a lot.
Eventually says maybe a host can map to multiple domains.
So a host can map to multiple domains. We map it on, so in the ingress object, when you put in the host, that gives us a specific one to map to. So you can, inside of a host, you can have multiple paths. So you can have one ingress object have multiple paths. So it might be gimli.com/ax/leather/ the one ring. And those paths map to multiple services for that perspective. But when you switch it and say go to Viking.com, that's a different domain. It's a different ingress resource, right? So I think that's the piece. So it's a host name. That's why I just shortened to host, the host name.
But you can do inter-domain routing, right? Maybe this isn't interesting. Yeah. Let's move on to the big stuff.
Yeah, because okay. So with ingress-nginx, we use nginx. So what we're doing, right? So ingress controller is watching for ingress resources, ingress objects to create that. So when we get that ingress object, we create the nginx config. So there are two pieces of software running inside our pod. We have the ingress controller, which is watching for the ingress objects being created and asked for. We take the ingress object and create an nginx config and pass that config to nginx. And that's how we do the mapping. And nginx is doing the load balancing for us. So the request comes in for an ingress object, ingress controller creates an nginx config and passes it to nginx. And so that's how we do the mapping between the two and how all of the software works together. And what Ricardo was talking about is when we set up the nginx config, we're mapping it to. Okay, sorry.
I'm not ready for Ricardo's knowledge. I have one clarification, make sure I'm understanding correctly.
Sure.
One is there are two containers running in the pod. So nginx is one of those containers and our application is the other container. Cool. What I think I want to do is write down like a step-by-step process of what you just said. Does that sound like a good use of our remaining board space to you? Excellent.
Yeah. So first step, right, is it?
Yeah. We have Ricardo's also on the case to figure out why host is used, the word host instead of domain. I love Kumar's question, like, why don't they just say domain? So maybe we'll get to the bottom of that by the end of the episode. That's exciting. Thank you, Ricardo, for doing that.
Thank you.
And Long says it's the DNS nomenclature is precise on domain, fully qualified domain name and host name. So there's, I guess, maybe within the similar for subdomain. So maybe in the DNS docs, kind of DNS literature, we can get to the bottom of what the difference is. And
That's actually a very good point because it does have to be I'm pretty sure it does have to be an RFC specific domain. So it has to adhere to the domains for that. So if you get an invalid domain, I think we'll spit it out and yell at you.
And then Spherics coming in. I guess you could have different domains in the DNS term sense and link this to the same common backend ingress-nginx. So client 1 sees Viking.com for their services and have another domain, new Viking.com, and that goes to the same service.
You absolutely can do that.
Mm-hmm.
So if you had multiple clients and each client had their own domain, but it's still going to the same service, that's why you have to have that tuple of the host, path, and service. That service could be the same for all of the host names. So that's a very good point.
Okay, so we're gonna go to this linear. So what? First of all, let's title it. What is it? What's happening? What's the life story?
This is the life cycle of an ingress-nginx object.
Love it. Object.
Yeah.
Cool. Okay. Step 1.
User requests new ingress object. So just new ingress object.
And that's where they define these 3 things, right?
Yep.
New ingress, just ingress object.
Yep.
And service host path.
Yep. And I'm looking at the docs right now. The official term is resource backend, which is the service that's running your application.
Okay.
Which is fine. So, we can leave that. So 2. Yep.
We have a question in chat.
Okay.
Sweetheart says, are ingress objects namespace scoped or cluster scoped?
Namespace.
There you go. That's the fastest question answer. Thank you for your question. That was a great question. Okay, so step 1, now step 2.
Ingress-nginx controller transforms the request to an nginx config.
Transforms?
But configures, manages, creates. Sorry, creates the nginx config based off of
what is that concretely? Is it a text file? Is it a running piece of thing? Like what is it a config map? What is it?
The nginx config is that it is a config, nginx.conf. So that's how you configure nginx and tell it where the backends for this service, where this request goes. So if you look at it, and you can dump this out, this is one of the troubleshooting things that we do is we'll ask folks to dump out the nginx config from the pod so we can see how that it was configured and see where the misconfiguration was. And that's what it maps out. It maps out. So it looks like a normal nginx config because that's literally what it is.
Cool.
And then 3 would be most likely an nginx reload because it has to reload that config, and then it can start accepting requests. A lot of other things happen too.
Okay, so nginx, which is the second, which is a sidecar running alongside your application. Let's just say that here.
Yeah.
It's not really a step, but nginx is running as a sidecar.
Yep. And it actually leads into one of the pieces of tech debt that we're working on, because we're running the controller software and the nginx software that does the proxying in the same pod. so they both have the same permissions. And that's an issue from a security perspective. So we're actually working on what we're calling the control plane data plane split, which is literally we're going to run nginx and the ingress controller in different pods so that we can assign permissions differently to them.
That makes a lot of sense. When you say ingress object, do you mean kind ingress in Kubernetes?
Yes.
Thanks for that clarification. That's great.
Yes, from an API spec perspective, that's exactly what we mean.
I'm not going to give that a step because it's not a step, but it is an important thing to point out right here. And then, and now step 3 is nginx receives the configuration and reloads.
And reloads, yep.
Okay.
What did you miss, Lewis? You missed Lewis, you're going to just have to watch the recording or schedule a meeting with me.
Or that's the beauty of having it all written on the board too. Like, read for yourself, buddy. And Fispheric says, what about, was about to ask if you're splitting the control and data plane. I guess that's about your separation of concerns that I honestly tuned out a little bit because I was thinking about what I'm doing here. Nginx receives config and restarts.
Yep.
Okay.
And then it's ready to and then you can receive the traffic and everything starts flowing.
But I don't think we've done enough to say what the to say the goal and that goal is achieved. Like the ingress-nginx object is created to get traffic from a domain name to an application, right?
Yes.
From domain to app. So
that
you
external
make your ingress
to internal.
External. So the user requests an ingress object, and then the nginx config is created and it's restarted. And now, without us needing to understand why, now the ingress that lets traffic into the cluster knows where to send the traffic.
Yep. So now end users can make a request on gimli.com/ax. User requests start flowing.
And users who can now access the app.
Yep.
Cool. Flowing. I like the word flowing. Excellent. Cool.
And when I talk about the pipes and making sure that everything works from the pipe, so now the pipe is complete. We have the pipe to the end user, to the application running inside the Kubernetes cluster.
So
as nginx at high level.
So as like a developer, that all I want is for traffic to get to my application. I don't have to concern myself too much with like the services and all the different pieces that we talked about here. So that's nice. Cool.
Yeah. Well, so that in step 1, that service has to exist. So they have to deploy that. They have to deploy their application separately of that. So Ingress won't deploy that service of your application. It has to exist outside of Ingress.
Okay.
So a developer has to do that work beforehand.
Okay. Cool. What about
go ahead.
More advanced things like tracing or rate limiting? Is that something that happens? Yeah. With Ingress, or let's say something else altogether?
So this is where we get into that previous question that we asked about very early on, was how do I configure annotations and do all this stuff? So if I want to set up SSL, for example, I have to have an SSL certificate. And so I have to add that into my ingress object. How do I do that? We do that with annotations. So you give the ingress object, you configure it with an annotation, and then we take that annotation and configure the nginx controller, the nginx config, and we point it to that certificate. So that's how we do that. So if it's an nginx module, we map it with an annotation. So this is how you get more
fancy stuff?
Advanced. How do we do fancy stuff? Yeah, annotations.
Okay. Short answer, annotations.
Yep. And those map to nginx modules. So folks who are used to running nginx and you have a specific need, those are broken up into modules. And so we map nginx annotations to nginx functionality in modules. So if you need a specific compression algorithm, we have an nginx module for that. There's an annotation that uses that. So yeah, when you want to get really fancy, that's why we have, I think the number that was quoted was 119. And let me go look at my notes, because this is the point where we start getting into the how complex nginx can be. We have 118 annotations, yeah.
Wait. Yeah. Are used to map. I don't like this.
I would just say, yeah. I would just say annotations. You can just say annotations, yeah.
Well, I want to say more. Like, so nginx has extra functionality via modules.
Modules are a piece of it, yeah. But then, again, so it's like on AWS, if I want to provision a network load balancer, that's an annotation. So I tell it to provision a load balancer of a network load balancer. It's an annotation. If I want to configure the AWS certificate from Certificate Manager, that's an annotation. So a lot of the options to configure the nginx config are done via options. So highly customizable from that perspective.
I have a couple things I want to ask and say. One is, I think it's good to say what annotations are. They're part of the metadata in a spec. I said spec, that's a bad word. In a definition file, right? Okay.
Yes. Yep.
Just so it's verifying
in the Kubernetes. Yep. So yes, thank you. Because again, assumed knowledge. In the kind object, when you create that, in the metadata, you add an annotation. So it's just like a normal Kubernetes annotation that you would put for a pod or for any other types of resources, extra metadata. We use that metadata to configure the nginx conf.
And that's a common way to go with networking layers. It's yeah. It's okay. So
Go ahead.
It's not just something ingress-nginx does. It's something other ingress implementations also do. And what were you going to say?
I don't know. Because at this point now, this is, like I said, go ahead.
What are some examples of this extra functionality that can be added via annotations?
So I would say maybe something like external auth. So if you needed to use like OIDC authentication, you would set up the OIDC authentication with that. The SSL certificates. If you wanted to do canary deployments, those are really good. We get a lot of questions about those three options, actually.
Okay. Cool. I didn't think about the canary deployments. Okay, so nginx has extra functionality via modules. Rate limiting, yep. Would tracing or like
I'm
observability
looking.
elements?
Yeah, because we've just managed to get the open telemetry module working, and if you
Oh,
want to use
nice.
that, it's an annotation to configure that.
And then how many did you say there are?
I think currently 120, 118.
118.
So it can get highly customized, and knowing which knobs to turn, we get a lot of questions on, is this annotation set up correct?
So you add / configure the modules via annotations.
And these are for individual ingress objects. You use annotations. If you want to configure all objects, like you want to require them to all use the same. I've not even looked into what the configuration options are, but if you want to configure them nginx as a whole, or all of the
Mm-hmm.
objects as a whole, you use the
Mm-hmm.
config map options. So in the config map
Okay.
options, there's 186 config options.
Wow.
This is the story I tell to help start to understand the complexity. When folks ask us a question, it's like you have to give us a lot of context to how you've configured it, what version of Kubernetes you're on, what version of ingress you're deploying, because we deprecate things sometimes. That's actually on our roadmap to deprecate some annotations and some functionality. So we have to know what version you're running on. We have to know what cloud you're running on and what
Wow.
the actual configuration is. So the complexity explodes very quickly, and that's what
Uh-huh.
I try to get across to people, and why I give them these numbers, because even that very simple question that we got earlier on about the annotation and why it wasn't
Mm-hmm.
working, there's so
Mm-hmm.
much context that's needed to answer that question.
Okay. And why you seem maybe a little bogged down as a maintainer of the project in terms of like you think someone's going to come on the stream and yeah, which I guess they kind of did. Um, we have a question.
I've expected it.
Is it possible that we can use node port type service instead of a load balancer service behind an ingress controller?
So this is where we get into the complexity of using a node port type. And from a client perspective, so an end user perspective, I have to know the IP address of all of those hosts. So in a cloud environment, if you've got 50 hosts in your cluster, you've now got 50 IP addresses to choose from. And that's why the load
Mm-hmm.
balancer is helpful. So you don't, from a configuration options perspective, you don't have to go back and configure and change that DNS to have those 50 IP addresses. So because if a host dies and you get selected to go to that one, DNS doesn't know about layer 7 or layer 4, and it's going to send a host to that one, and they're not going to be able to answer that request. That's why the load balancer in front of it is helpful, because it has health checks and say, is this application still running, and can I serve traffic to it? So the differentiation between the node port and the load balancer is just an ease of use from an end user's perspective. It is possible. Yes, you could do it, but what is your use case?
Yeah. So we use a config map Kubernetes objects to configure Nginx as a whole, and you said there's
Yep.
another 100 something what?
186. So
186. What though? I don't have the mental model
conf-
of like what's happened.
so let's see. So configuring mod security. So if you want
And
to turn
then
on mod security.
and then that's just like a field in the config map.
That we'll
Okay.
read from. So most of these are like booleans or numbers. So let me look at
Okay.
another one. So like
One. I'm gonna get examples. So yeah.
like the SSL protocol to set as a whole for all of the ingress objects.
Okay.
Excuse me. I dropped the link in there if you wanted to send it to other folks. But yeah, so if you want to configure them as a whole, there's a bunch of different options that can influence the traffic and where it goes.
Okay, TLS config as a whole. What else?
Um, so this is a good time to talk about from a security perspective. If you want to disallow, so we had a CVE issue a while back where someone could grab secrets from the ingress controller by a well-crafted snippet. So a snippet is a configuration option, and you can disallow those as a whole. So from a security and admin perspective, you could disallow snippets. So the config
Okay.
map overrules the annotations. So you could, from a security perspective,
Mm,
you could disallow snippets as an annotation. So that's a good example.
okay.
You can set global rate limiting. So instead of doing it per ingress, you can set a global rate limit for everyone.
Cool.
I feel like I kicked the hornet's nest. We got 4 new comments. Oh no, those are you posted the links. Okay.
So 186 of these, you said.
Yep.
Am I still on the board? Yeah. Cool. I don't know how much you had planned to say, but we're running low on board space, but we still have a little bit. But
Yeah,
use it wisely.
I think I talked a little bit about the CVE remediation, and I've got a whole other talk that folks can go and listen about that, about how we walk through. We've actually, and I just wanted to call out Dylan Turnbull. He's been helping us from the nginx Inc. He's a developer advocate, or I think he's a dev advocate, but he's helping us to get more traction inside the nginx Inc. organization. Just helping us from like a CVE remediation support, getting actual contributions back to our project. So we did a talk at KubeCon, and we talked about the nginx CVE remediation, which that affects millions of users once they have a CVE, and then
Uh-huh.
as they get a new CVE, we have to implement patch fixes and things like that. So it was a really
Yeah.
great talk. I guess folks should go talk out. Again, just a little bit more of the complexity. Right?
Okay.
We talked about the 2 containers that we help
Uh-huh.
maintain.
Uh-huh.
One's in Go and one's the Nginx config. We have to maintain those, but we also maintain like 12 other container images for our testing, our end-to-end tests. Yeah, we've got about 400 end-to-end tests. So when we go to cut a new release, it takes about 4 hours because we compile Nginx. We have to test against 4, maybe 5 Kubernetes versions and
Wow.
against our Helm charts. Yeah, so it starts to explode again very quickly. The complexity of like all of the use cases. We run end-to-end tests against all of those annotations. I like to say all of them, but we've been working on a new feature of annotations, what we're calling like annotation sanitization. So making sure that an annotation has documentation, it has a test, and it has a validation function. So we're doing a lot right now to help maintain and manage the complexity and hopefully make it easier to use.
Do you ever have problems with annotations conflicting with each other? Like if you happen to install these 2? Yeah, that's the thing.
Absolutely. Yeah. Yep.
So maybe
That's
the
that.
sanitization can help prevent that from stepping on
Yeah.
each other's toes.
Yep. So one of the things that we really didn't talk about, so like when we talk about step 3 or step 2, when ingress-nginx receives an ingress object, we have an emission webhook that tests it. So if it's a broken config, before we even, because nginx will reload, but we'll give users feedback and say, hey, something's broken about this. We can't apply this config. So we're trying to think about that from a developer's perspective. If you want a new annotation, you have to do all of those things: documentation, input validation, and testing.
Cool. And so maybe like you're talking about the complexity, but you were talking about the complexity, it sounded like from a maintainer's point of view in terms of like all the tests that you need to run before a release goes out. Maybe we can reserve
Yeah.
the space to talk about the complexity from a user point of view and maybe just
Okay.
list out. Oh, and we have a question from Physic, so let's get to that first.
We get this question a lot too.
Is there a reference for the recommended resources for the ingress-nginx needed to run for CPU, memory, disk space, etc.? Because more modules running would need reasonable specs for compute and processing. Great question.
It is a good question. It's been on the backlog for a while, and unfortunately, I don't have a good answer. We have defaults in the deployments. We are looking to add performance testing. We have some that we've looked at using a technology called K6, but we haven't expanded on changing configuration options and then doing performance testing. And I know there are some options like the open telemetry module. Once you enable that, that consumes more memory, and so we know that we need to add performance testing between releases so that folks can understand how they need to configure nginx. So like we'll get excuse me, we'll get folks who are running thousands of ingress resources, and it just bogs down the controller because it's not properly configured, and we don't have any guidance on that. So that, unfortunately, that's one of the things that's on the backlog that we're trying to get to. But there are other things like the releases, the CVE fixes, all of the other things. But it is on the backlog to try to get folks performance numbers and configuration options so that it can scale appropriately. Because we get a lot of questions about like horizontal R scaler, C groups, and so it's a long-winded answer to saying no, we don't have. We have it defined as a default, but as you scale up, you have to scale the resources, and we don't have guidance on that, unfortunately.
I have a question. When is like if I was just implementing ingress and just looking at all my options, why would I choose one based on nginx? Like, what's the difference use cases for one based on nginx versus one based on Envoy?
I think that's probably a question better for Ricardo. I'll answer it with just going back to the initial need. The founding maintainer, I think he just picked nginx because he was most familiar with it, and he knew how to configure it and those options. But again, like I would say, I'm near and dear to my heart, ingress-nginx. But I would say again, just do a bake-off. What's the features and functionality that you need? Does the ingress controller provide those features and functionality? Performance testing, things like that, and go with the one that's best for your options. Whether Envoy or nginx, I can't really say, but I would just say use the one that's best for your use case. And if you pick ingress-nginx, let us know.
Yeah. Is that something that's easy to determine? Could you just like look at the docs to see, or is it more you just play with it? What would be your strategy of?
I would definitely just start looking at the landscape of the applications and what the developers' needs are. So like we talked about some of the other configuration options, like the global auth. Do I need telemetry? Do I want to move to open telemetry? Does it support that? So again, just start with the customer use cases, the developer use cases, see what features and functionality they need, rack and stack them, and then compare that to the ingress objects. I don't have it saved, but there was actually a really good spreadsheet on Google Docs that someone was maintaining about features and functionality, and I really wish I had that to share with you all, because it was a good one where you can just say, I need this feature. You go down the cube and you say, hey, yes, it supports that one. I forget who is supporting that.
If you find it, let me know and I'll put it in on the YouTube video of this. I'll put it in the comments.
Okay.
Or if you give it to me now, I'll put it in chat. So we have this little bit of space left. I think it could be used to talk about the complexity, or it could be used to talk about considerations when choosing an ingress, or it could be used for something completely different altogether that you know and I don't know yet.
I did want to give us a little time to talk about like our future work and what we're focusing on
Ooh,
as maintainers. I do
yeah,
have a
let's do
couple
that.
objects
Yeah.
because, like I said at the very beginning of this talk, getting the word out about what we're doing as a maintainer and as maintainers and as the community, as many mediums as I can, because folks miss things. So one of the new things that we've done, right, is that we've got access to our Twitter handle now. So that's a new medium. So we've got Twitter. We created a Ingress Dev Google group. So on top of that, so when new releases go out, they'll go out on the Google group. We'll tweet them out. We drop them into the user channel. So I'm trying to do as many communication mediums that I know of to put the word out about things that we're working on. So that's why I wanted to talk about it from this perspective. One of the big ones, right, that we talked about earlier was the control plane and data plane split. So helping to increase the security of ingress-nginx by breaking those two off. The annotation validation, sanitization that we've talked about. I think that's actually waiting on me to accept that PR. Ricardo would probably know more.
Annotation sanitization.
Yeah,
Cool.
so that's what we talked about, the validation, the testing, and making sure that the annotation works and does exactly what it says it does. We get a lot of folks asking about Gateway API. We are marching towards Gateway API. The security of the ingress-nginx is probably would be helpful with the Gateway API implementation, but we're still working on securing ingress-nginx. One of the other things that has come up is being able to run this as rootless. That's been an ask. I think I've got 3 open issues of folks asking to be able to run ingress-nginx rootless, and that requires a lot of changes internally to Ingress, because Nginx writes a lot of files to different locations, so we have to configure all of this. So I think the split will help with that, and also just maintaining and managing that, and being able to run that container as rootless and read-only. But that's going to take a lot of effort and a lot of testing. We've got 2 things coming down the pike that we need people to be very aware of. One of them is the deprecation of mod security. So Nginx Inc. themselves and several others are deprecating mod security because the corporation that's supporting it is now relegating the control of it back to the community. And I think it's next year. I think it's 2024. But I haven't caught up with that about where mod security is at from that perspective. So it's a concern. So we're going to mitigate that risk by deprecating mod security. We don't have a roadmap on it. We don't have testing. But again, as I talked about, we're going to put out all of these deprecation warnings and these feature breaking changes on those mediums that I talked about. And we talk about this in the community meeting. So again, I'm trying to get more folks involved that are using it, right, to understand where we're coming from and why we're doing the things that we're doing. So mod security being deprecated is one of the ones we've been talking about for, I think, at least 6 months now. And then one that's coming out really soon that we tried to do, where I learned about some breaking changes, is the path validation. So that host and that path is very configurable as well. And we have to do a lot of validation on, do you have access to it? Is it the right path? Are you trying to do things like grab a security token or an SSL cert? And so we're doing a lot of validation on the path type. And again, we're going to try to have a lot of noise about that before we release it, and just get it out to the community. So that's a lot of things that we've talked about. But again, we talk about these in our community meetings, in those Slack channels. And if anyone has any questions on those, please join those mediums and ask.
And contribute if you want to. Oh,
Absolutely. We always need folks looking at documentation, clarifying those annotations. So it's not just code contributions. It's, we've got a whole test framework. We had a new contributor that talked to us after our KubeCon EU talk. He came and he did a very meaningful, impactful change to our testing framework. So I greatly appreciate that. Thank you, Brandon.
Ricardo's joking around. The biggest feature set is just validating things more and removing features. Smiling.
So that's the thing, right? Is that there's, we talked about those 118 and 186 configuration options. We'll get someone who come in and will ask for one, and then they'll do the code changes, and then there's no one else to maintain it afterwards. So it leaves the burden with the core maintainers. So it's just looking at, if you're using a feature and a functionality, please let us know. Not everything's on the chopping block, obviously, but it's like, things that aren't being maintained, aren't up to security snuff, things like that. So again, if it's something you're using, please let us know and maybe possibly look to contribute to help maintain it.
Excellent. So what I'd like to do, if you're finished if you've said everything you feel like you want to say, what I want to do is do a recap. So I'm going to repeat to you everything you've taught me today, you've taught us today, and verify that we have a good understanding. How does that sound? Are we ready for that step, or do you have anything else you'd like to? Is it time for a recap? Okay, so
yeah, that sounds good to me.
Excellent. So today, to give context, I started by talking about the Kubernetes networking model. So how Kubernetes objects are networked together at a high level. So you mentioned four steps, four aspects of the networking model. So highly coupled container to container communications. And in that case, we need containers of the same application running in different pods. And so we do that via the pod IP addresses. So those are all connected to each other. We also have a pod to a service communication. And so that's the service we drew here. The service knows about where all the pods are and gives them a unified IP address. So services group pods that are all running the same application. So then we have external to internal communication is a layer of the Kubernetes networking model. And so that has to do with getting traffic into the cluster altogether. And then also we talked about container to container communication again, but this time two containers running in the same pod. And those they share the same network and they can refer to each other as localhost. So we took the time to draw all of that out here in our Kubernetes cluster. And then we also talked about the endpoint being where the service meets the pod. And we also talked about CNI, which stands for Cloud Networking Interface. So the CNI is drawn here between a kubelet and a pod, but it would exist on every, what did you call it? You called these hosts instead of nodes, which is extra confusing now that I know that we call this a host too. It's ridiculous.
A host has a host name. Machine. A host name can be a domain name, but it's container networking interface.
Oh yes. Great. See, that's why we do this.
Mm-hmm.
Great. Okay. So the container networking interface is responsible for the pod networking on the host. So the host being the machine, the single machine that's part of the Kubernetes cluster, a worker machine in this case. So it's responsible for the pod networking on the host machine. It's the interface between the kubelet and the networking for a pod. And there are many implementations that follow the cloud, the CNI, because it's a standard. The CNI itself is a standardization. And then it connects new pods to the Kubernetes network that container networking interface does. It could almost be called a pod networking interface based on how we're talking about it. Is that accurate? I might be opening a can of worms.
You can have multiple containers in a pod, but it's specific. the container, one container or two containers inside of a pod use the same IP address. So it's still container networking. Again, the pod is a Kubernetes aspect. So yeah, the CNI, that's why it's separate, and that's why, again, it's very specific. You have the container networking interface, container storage interface, container runtime interface. So it's still around containers, but it's also Kubernetes. The pod is Kubernetes specific.
Got it. And so then we talked about Kubernetes service type. So we talked about a cluster IP type, which is the default type if you don't specify, and it enables service to service communication. So different parts of an application, like a front end to be able to talk to a back end or whatever, to be able to talk to each other. A node port enables host to service communication. And then a load balancer provisions an external load balancer and then also provisions the node ports for you too. So it sounds like a load balancer provisions that external load balancer that traffic hits before it even gets in the cluster. And then it also provisions on the inside of the cluster another service to help the traffic move around once it's inside of the cluster. So even though, yeah, it sounds like this is maybe a node port service that's provisioned by the load balancer.
Because they build on each other. Because I think even a cluster IP service also does a node port, because it has to. That's how it does the mapping of the traffic. So they all build on top of each other. Because I don't want to say node port was first, but the node port does the host, the minion, the worker to the pod traffic, and then cluster IP. Because again, we didn't really get into the very complex and confusing IP tables, rules on how all of this stuff is maintained and managed. But again, that's yes, that overview is enough for the 2 hours that we have.
Only 2 hours. So when you deploy an ingress controller, so it gets a little confusing. There are a lot of reasons talking about ingress and untangling ingress is confusing. And one of them is that there is an ingress object, a Kubernetes ingress object, and then there's also a Kubernetes controller, which is the implementation, which is watches that object. So when you deploy an ingress controller, it deploys all of the resources to manage ingress objects. So it'd be just like adding any other Kubernetes add-on we said. It's like ingress controller pods, namespaces, RBAC, config map, just like you were doing any Kubernetes add-on. The ingress controller watches for ingress objects. And then it helps create them, and then once they already exist, it makes sure that they stay in the state that they're defined to be in. So an ingress object then is the mapping between a domain and the running application. So the running application can be represented as the services in the pods.
Yes.
So
one of the things I wanted to add here, if you cannot specify a domain, and then you get what's called the default. And the default, so if you have a default backend, it just goes to that one. So again, the domain is to help differentiate from a client's perspective and from just a different object. So again, it's just another piece of the puzzle for differentiation. So you could not
Does
specify
it definitely
host,
have a does it definitely have a default?
It's optional.
It can have a default.
The host is optional, and we actually deploy a default backend for you. And it's just the normal, like if you get a 404, it's the normal nginx 404 page. So if you don't define a default backend, we give you one. So if it can't map it, whether it's the host or the path, if it doesn't know how to manage and answer it, we give you the default backend. And that's a configuration option that you can specify if you want a different default backend. See how it all ties together?
And that's a cluster wide, so it would be in the config map as opposed to being in the annotations. Okay, wow. So finally, like over an hour in, we finally defined what ingress-nginx is. So, well, let's say as part of the ingress object, we have to define a service, a host, which is the domain name, and a path. So more specifically to just like Viking, Gimli.com. So then an ingress-nginx is a Kubernetes. I didn't know ingress. I forgot a word here.
Ingress, yeah.
Yeah.
It satisfies the Kubernetes ingress API.
Ingress implementation.
Yeah.
Okay. Ingress-nginx is a Kubernetes ingress implementation that uses nginx to maintain and configure ingress objects. Excellent. So that's our definition. And then we also say not to be confused with the nginx Inc. ingress controller. So next we talked about the life cycle of an ingress-nginx object. So the goal of an ingress-nginx object, as we said, is to get traffic from the external domain through to the application. So the first thing that would happen is the user would create a new ingress object. And so in that, they define the service, the host, and the path, just like we talked about. The second step is that the ingress-nginx controller creates the nginx configuration. So that's an nginx.conf file. So first it goes through an admission webhook to make sure what you're asking for is possible. And then it makes that file. And then it gives it to the nginx, which is running as a sidecar in the same pod as your application. So then the nginx receives that configuration, it restarts, and now the end users, now the traffic is flowing. The end users of the domain can now access the application. So that's how it works at a very high level, but then there's lots and lots and lots of complexity, which, yeah. So there's a lot of additional capability in nginx, and that capability can be either cluster scoped or it could be scoped to your specific ingress-nginx object. And so if it's scoped to just your objects, then you're adding that functionality through the annotations, which is a field in the definition file for your object. And so when you add annotations, some examples are, so what you're actually adding are nginx modules, and you say which modules you want to use via annotations. And so some examples of modules.
Yeah.
Do you want to finish that sentence?
A module, a module could support multiple annotations. So I think we only install like 30 nginx modules. So to configure those modules, it maps to the 118 annotations. So yeah.
Okay. Interesting. Okay. So I'm gonna write that 30 modules. You said about.
Yeah, about 30 modules, and mod security is one of them, and that's one of the ones we're deprecating.
About 30. Okay, so about 30 modules that then have about, between them all, have 118 different ways to configure, or configurable aspects of them. And so examples are external authorization, TLS certs, canary deployments, rate limiting, or open telemetry. But then you might need to configure something that's scoped cluster-wide, and you would use a config map object to configure that as a whole. Would you use one big config map or lots of little ones?
It's one big config map.
Okay. So you might want to configure TLS.
Because that config map also, because remember you can have, in an nginx config, you can have global sections, and then you have like resource specific ones. That's what's configuring the global section of the nginx config. So again, we take the ingress objects that we are asked to configure, we take the annotations, and we take the config map, and then we produce the nginx config as a whole and push it to our nginx workers. So the ingress controller is responsible for all of that. We're doing a lot of parsing, validation, and then we generate the nginx config and push it out. So all of that lives in the controller.
Cool. I'm going to label these app. Am I on the board still? Okay, nginx.
Yeah.
Okay.
Okay, I wasn't sure that's what. So your app is going to be in a different pod in a different service. The nginx pod and the ingress controller pod are all they're two containers running in the same pod. Your service is running in a completely separate one. Yeah. So it's not like Envoy proxy. You have the proxy sidecar
Uh-huh.
in a service mesh example. Ingress-nginx, the controller and the node and the nginx are running in a different pod, and we're proxying to the application pods.
So this is an Ingress controller container.
Yeah. Yeah. And then we're
And then
proxying to
that's an
your
Nginx.
service pods. Yeah.
I hear you, and I want to capture that, and I'm just like looking for real estate.
Yeah.
Um,
It's fine. I think the idea is that,
okay.
right, Nginx is standing up alone in its own pods, and we're proxying to your services that were defined in the ingress object.
Okay. That makes sense. And I'll just say, uh, ah, it'll be fine.
Yeah.
So the Nginx is what's doing the proxying, or the Ingress
Yes.
controller. Okay.
The Nginx. So see, this is where when we
Okay.
talked about like the security concerns, Nginx
Mm-hmm.
and Ingress are running in the same pod. They have the same permissions, and Nginx doesn't need the
Ah.
same permissions as the controller, and that's why we want to separate them.
Um,
This is why recaps were good because I'm glad I could
yeah.
clarify that point.
Proxies to app. Cool. Great. That's wonderful. So we use config maps to configure Nginx as a whole. So example would be TLS configuration as a whole, disallowing certain annotations from being allowed to be used in your cluster, set global rate limiting, and there are 186 different config map things you can use. So when you consider all of the different options, it's quite a complex beast. And maintaining all of the modules and options and then making sure they all play well together, it's a lot to consider, which is some of what's going on when we talk about the future of Ingress Nginx is to improve how this ecosystem of add-ons. So we talked about the control plane, data plane split. So having these two in the same thing. Which one are you? The control plane is probably the controller, and then the data plane is the Nginx. Yeah. So splitting them
Yeah,
maybe,
yeah.
and that's an upcoming thing is to split out those separation of concerns. Annotation sanitization, so to have validation and testing and some standardization for the different annotation choices. Gateway API
Mm-hmm.
compatibility, which is big with any Ingress anything. That's another vocabulary thing that was hard for me at the beginning. Like an Ingress implementation is the same thing as a gateway. Like those things can be used interchangeably, and that's confusing for me.
So it's about who can deploy what, right? So it breaks out from a roles perspective. Actually, I think I'm gonna ping Scott, and he probably should come on and talk about Gateway API because he's running that.
Okay.
I think he's running that SIG. I I got you.
Oh, nice. Yeah. Let's see. Um, and then we have running the Nginx container as rootless and read only. Why do people want to be able to do that?
Well, if you're one of the good options is to, if you can't run as if you're not running as root, if that container gets compromised in any way, it doesn't have the
Good.
privileges to do anything from that perspective.
Okay.
And if it's read only, then you can't make any change. If you do get inside that container, you can't make any changes. So those are two really good security concerns. So if you can, running your containers as rootless and read only, that helps improve the security bar.
Yeah. Excellent. And Ficeferic said the same thing, but run the services with the least amount of privileges, like across the board. That's the way to go.
And one of the problems with the ingress controller is that we need to have access to the TLS secrets, and
Mm.
the Nginx doesn't need access to those or the service
Mm.
account token to do all of these ingress things. So splitting those apart separates the security concerns and the privileged concerns. So we can reduce the Nginx data plane, and again, it's all about increasing the security of ingress Nginx.
Excellent. So, and then relatedly, the deprecation of the mod security module is on the horizon, and also path validation is on the horizon. So those are some things coming up. If any of them sound interesting to you and you want to contribute, do it. And so are you gonna do a little like comedy routine for us while we wait for Scott to come on and talk about Gateway API?
Oh, no. All of my extrovert points have been spent now. I'm just gonna sit and do some code and not go to any meetings. Like you've gotten all of my extrovert points for the day. Maybe the rest of the week.
Yeah, I'm pretty spent after one of these episodes too. So
but
for real,
this was a lot of fun and a lot of information.
Yeah.
Oh no, I meant like have him do a whole separate session, and then Rob Scott.
Oh,
yeah.
Okay.
I think he could do a whole episode on Gateway API. Yeah.
Okay. Yeah. I thought like, okay, we're waiting for this guy to come on and talk right now. So cool. Yeah, and I know that if we're gonna do a contour episode tomorrow, and we're gonna talk about Gateway API. I know as part of that one too. So we'll get to the bottom of it some way somehow. So I need you to like scrounge up just like one or two more extrovert points, because we're gonna Vice says haha comedy, thought was watching Tanzu Happy Hour extended. Yes, it is. So we're going to dance it out. That's how we say goodbye on Enlightning. I'm gonna replay the intro music and we're just gonna dance a little bit and wave a little bit. My brother wrote this song.
That's fun.
So we're going to say goodbye. Thank you so much for being a guest. Thank you, James, for coming on. Thank you, everyone in the chat. Thanks for people that watch the recording. Yeah. Have a great rest of your day. Bye.
Bye, everyone. Thanks for coming. This was awesome, Whitney.
Thank you.
So much fun.